Hi, and welcome to today's video lecture. Today we're going to talk about solving linear equations. So first, let's start out with a little vocabulary. First, a solution. A solution is the numbers that make an equation or inequality true. So when you solve an equation, solving an equation, you are algebraically manipulating an equation so that the variable being solved for is by itself. And you do this by applying inverse operations, add, subtract, multiply, or divide by, for example, using the order of operations backwards. So you're used to using, when you're simplifying expressions, you're used to using order of operations. Now when we solve, we're going to use order of operations backwards, and we'll do some examples of that here in just a second. So always remember, whatever you do to one side of an equation, you must also do to the other side of the equation. So if you are subtracting something on one side of an equation, you have to do the same thing on both sides of the equation. Okay? So let's look at some examples here. First of all, we'll start out with simple one-step equations. So in our first example, solve x minus 3 equals 4 for x. And I'm not always going to write for x. Because that's kind of, if we're solving for the variable. That's kind of the point. So I'm not going to always write that. So the first thing you want to do always, especially in your homework, is copy the problem. So we've copied the problem. And so notice that since we have minus 3 here, the inverse operation of subtract is add. So we're going to add 3 to both sides of the equation. So by doing so, we get x plus 0, because negative 3 plus 3 is 0. So x plus 0 equals 7. And remember, the identity property of addition says that x plus 0 is just equal to x. And so we can simplify that down to x equals 7. Now, we don't always have to do this step here, but I did want to show that to you just for illustration purposes today, that we should end up with the variable plus 0 when we're solving our equation. So we end up here in this case with x equals 7. Now, one common mistake to watch out for is a lot of times students see the minus, and so they want to go ahead and minus 3. And of course, you would get a different solution here. You would get x equals 1 if you subtracted 3. But remember, if you subtracted 3 on both sides of the equation, negative 3 minus 3 gives you negative 6. So it would give us x minus 6 on the left side, not just x by itself. So be careful of that mistake. That happens fairly often when students are just starting out with equations. Okay, next example, solve 1/3 x equals 2. So remember, we're going to copy the problem, and we are going to multiply by the reciprocal of the fraction. So remember, when you see a fraction, think of multiplying by the reciprocal of that fraction to get rid of it. So 1/3, the reciprocal of that would be 3. So 3 times 1/3 gives us just 1x. And 2 times 3 on the right side gives us 6. And I did make a note here just as a reminder, when we're dividing fractions, you could think of this, well, since this is 1/3 times x, we could divide by 1/3. And if we take 2 divided by 1/3, well, that is the same as when we're dividing with fractions, we take the second fraction, flip it over, and multiply. So it's the same as 2 times 3 over 1. So really, we're doing the same thing if we divide by 1/3 or multiply by 3. It's the same operation in the end. Okay? And remember, the identity property of multiplication says that 1 times x is just equal to x. So we get x equals 6. Okay? Check your work. So 1/3 times 6, is that equal to 2? Well, 1/3 of 6 is 2, so yes, 2 equals 2. It does check out. So remember, when you're working these, always check your work just to make sure you've done all the steps properly. Okay, we'll get a little more complicated here. We're going to go on to two-step equations. So in our first two-step equation example, solve 3x plus 5 equals 14. Now remember, order does matter. We do want to work order of operations backwards. So the first thing we are going to do, so if we think about this, what is happening to x? Well, the first thing we would do normally is multiply by 3 and then add 5. So if we're thinking order of operations backwards, we're going to do the inverse operation of the add first, which is subtract 5. So if we subtract 5, we end up with 3x equals 9. And now we can go on to multiply and divide. So we divide both sides by 3, and we get x equals 3. So, of course, we do want to check our work. So if we put 3 back into the equation, 3 times 3 plus 5, is that equal to 14? Well, 3 times 3 is 9. 9 plus 5 is 14. Now, you don't always have to show your work on your check on your paper. You can kind of do this mentally. If you think 3 times 3 is 9 plus 5, that does equal 14. So if you do a little mental math here, that's okay. I don't mind that. But it is important to show all of your work when you're solving your problems. Okay, next example. X minus 8 over 2 equals 3. So in this example, we kind of have to think of things a little bit differently. What's up here in the numerator we have to think of as being in parentheses. This is all one thing going on here. And we're dividing this entire thing here by 2. So since we have to think of that in parentheses, we have to do what's in parentheses last for order of operations. Okay, so in this case, what we're going to do is go ahead and multiply by 2 first. So first, copy the problem. And then multiply both sides by 2. So if we cross cancel here, we would end up with x minus 8. And on this side, 3 times 2 does give us 6. And now we can go ahead and do the addition. Since this is all by itself now, we can drop the parentheses. And we add 8 to both sides. So we get x equals 14. Okay, so check your work. If we put in 14 minus 8 divided by 2, well, that's 6 divided by 2, which does equal 3. Next, we're going to move on to solving multi-step equations. So these equations are a little more complex. They take a couple more steps than just 1 or 2 steps. So here is the problem. Solve 4 times the quantity x plus 1 plus 2 equals 10. So, of course, the first thing we're going to do is copy the problem. So we've copied it here. And remember, we are going to work order of operations backwards. But I am going to show you a couple different methods of doing this. But first, we need to get this term here by itself. So we're going to subtract the 2 from both sides. And that would be first thing in order of operations is to subtract the 2. So we get 4 times the quantity x plus 1 equals 8. Okay, from here, I'm going to show you 2 different ways of doing this. First way, I've just copied the problem on down here. Remember, if we're working with an expression, we just work order of operations like normal. And so think of this left side. We're just going to simplify the left side a little bit here. So apply the distributive property. If we do that, multiply everything in the parentheses by 4. So we get 4x plus 4 equals 8. And now we can just solve like normal. So subtract 4 from both sides, giving us 4x equals 4. And then divide both sides by 4, so we get x equals 1. On the other side, the other method we can do, if we're thinking about order of operations backwards, remember after we subtract, the next thing we can do is multiply and divide. And our parentheses would be last. So let's go ahead and divide both sides here by 4. And when we do that, we get what's left inside the parentheses by itself, which is x plus 1, and 8 divided by 4 gives us 2. And now we can go ahead, now that we just have the parentheses by itself, drop the parentheses, and start working again backwards. All we have is the x plus 1, so we're going to subtract 1 from both sides, and we get x equals 1. Okay, remember we do need to check our work. So let's put 1 back into our original equation. 4 times the quantity 1 plus 1 plus 2. And so I've put that right here. Is that equal to 10? So do inside parentheses first. 1 plus 1 is 2. Now go ahead and multiply. 4 times 2 is 8. 8 plus 2 is indeed 10. So we have 10 equals 10. It all works out like it should. Okay, so far we've worked with a lot of equations with a lot of numbers in them and only one variable. Now we're going to work with some equations that have multiple variables, only we're going to solve for one of those variables. So, solving for a variable, these are called literal equations. So if you see the term literal equation, that just means that there's multiple variables in that equation, and usually what we're going to do is solve for one of the other variables that it's already solved for. So in the equation, A equals B times H. This is area equals base times height. We're going to solve for B. So if we had a problem where we knew the area and we knew the height, if we solve for B, we can just plug those numbers in for the area and the height, and that would give us our answer for the base. Okay, so that's kind of the reason why we would want to do this. So copy the problem. A equals B times H. Well, we're solving for B. So, and B and H are being multiplied together. So use the inverse operation, of course. Divide both sides by H. And we get A divided by H is equal to B. Or, if we just reverse the order, B is equal to A divided by H. Same equation, we just reverse the order. Okay? Next example. Using the equation for area of a trapezoid, solve for H. So this one's going to be a little more complicated. The area of a trapezoid, A equals 1/2 H times the quantity B1 plus B2. You might remember that from geometry. So I want you to think of this as 3 different things being multiplied together. It's 1/2 times H times the quantity B1 plus B2. Okay, so this is all one thing here. If we knew what base 1 and base 2 were, we would just add those together. So this really is just one number here. Okay, so remember, first thing, we kind of want to get rid of this fraction. So multiply by the reciprocal of the fraction, which is 2 over 1. So multiply both sides by 2. And we get 2a is equal to the height times quantity, base 1 plus base 2. So now we have 2 things being multiplied together is all. So we just need to divide by everything else other than the h, which is b1 plus b2. So divide both sides by that b1 plus b2, and we get h is equal to 2a over b1 plus b2. So if we knew all of these, what all of these were other than h, we could easily plug in all of those numbers and solve for h really quickly. Okay, and our final example. Solve r times the quantity r1 plus r2 equals r1 times r2. So this is probably our most complicated example so far, and I don't think you will see any that are any more complicated than this in your homework. We want to solve this for r2. So first we're going to, of course, rewrite the problem. So I have done that here. And the first thing we want to do in this case is simplify one side a little bit as much as we can. So we're going to do that using the distributive property. R times R1 plus R times R2 is equal to R1 times R2. Okay, so remember the goal is we want to solve for R2. So in order to do that, we need to make sure we get R2, all of the terms with R2, to one side of the equation. So to do that, we need to subtract R times R2 from both sides. And here's our result. R times R1 is equal to R1 R2 minus R R2. Okay, so now we need to think of a little trick. How do we get only one R2? Because that's what we're solving for. we only need one R2. We can't have multiple of those in our equation. So to do that, we're going to use the distributive property, only it's going to be a little different. We're going to use it backwards compared to what you are used to seeing. So we're going to undistribute the R2. We're going to take that back out. So we end up with R times R1 is equal to R2 times the quantity, R1 minus R. And now we're almost done. We just need to divide both sides by R1 minus R. And so when we do that, we get R times R1 divided by R1 minus R is equal to R2. And that's it. So I hope all of these examples help you out. And I hope to see you again soon. Thank you for watching.